Hey guys, we're on Unit 5. This is day 11, and our lesson is about, is it growth or decay with a manipulated percents? So it says, when an exponential model is in y equals ab to the x form, we say that r is the growth rate or the rate of growth. Oftentimes in advanced math, we come across scenarios where the b to the x must be manipulated to get a proper rate of growth. Okay? So what happens with these is that it's so easy to tell whether an equation or function is growth or decay based on the base. And we can go ahead and judge a function, whether it's decay or growth, based on the base if the exponent is just an x, like we've been seeing. However, if the exponent is not just an x, like in this first one below the black bar here, then we cannot assume that this is an accurate base, that exponent on that base could change that base, and then it could change it to be greater than 1, and therefore it would be growth and not decay like we thought it was going to be. So with that in mind, we have to remember that our exponent needs to just be an x in order for the base to be a true base, and then we can judge it if it's growth or decay. All right, so in this first one, what's nice is that that is just an x, and therefore that's our true base. So our base is 3. And when our base is 3, or our multiplier, remember that's what I call it, is 3, and you multiply by 3, we're going to end up with growth. Okay. And what is our rate of growth? Well, that gets a little bit tricky, but there's an easy way to remember that when you're looking for that R value, just remember that if it's growth, it's 1 plus R, and then we're going to solve for R. Now, if it's decay, we have to remember that it's 1 minus R. Okay, so since this is growth, we're going to go ahead and put 3 equal to 1 plus R. We're going to take 1 away, so we get 2 is equal to R. And then you have to remember that R is our rate and that it needs to be put back into a percentage form. So if we take 2 and we multiply it by 100 to turn it back into a percent, our 200% is our rate. And so this is growing by 200%, just growing fast. Okay, let's take a look at the next one. Again, the next one's not that bad because our exponent is just an x. And when our exponent is just an x, our base is a true base. And now we can go ahead and state that our base is 0.87. Since 0.87 is below 1, but more than 0, we're going to end up with decay on this one. Okay. And because it's decay, we're going to go ahead and set that 0.87 equal to 1 minus R. Okay. And therefore, we're going to go ahead and solve for R. So we're going to go ahead and subtract 1 and divide by a negative 1. And we end up with 0.13, which as a percent is 13%. And there's our rate. All right. Next one up, not that easy. So what we have to realize is that in order to get this exponent to just be an x or an h, it doesn't really matter what letter it is, this one's going to be an h, we have to get rid of the 2. And so we're going to take our base of 1/2 and we're going to raise it to the second power. Okay. What that does is it changes our equation to h of x, h of x is equal to 3. 1/2 raised to the second power is 1/4 or 0.25. And then this will just become the h. And so now you guys can see that the base now is a true base of 0.25. Because that's less than 1, this will give us decay. And our rate, because it's decay, we're going to put that 0.25 equal to 1 minus r because it's decay. We're going to subtract 1 and we'll divide by a negative 1 so that our r comes out to equal 0.75, which as a percent is 75%, and that is our r value or our rate. Okay, go ahead and try the next one. So in this one, again, your variable is not just x, okay? It's x over 3, which we have to realize right in front of that x is a 1. And so technically, this is really 1/3 x, or x divided by 3. And so we're going to take that 1/3, and we're going to take our base, and we're going to type all of that into our calculator. Okay? So that we're basically rewriting the equation to be w of x is equal to 2 raised to the 1/3 power is 1.2599 ... But now it'll just be raised to the x because I typed in the 1/3 on the 2. Okay. And now that that x is just an x, then this is our true base, which is 1.259 ... Okay. Because it's over 1, this indicates growth. And because it's growth, we're going to take that decimal and we're going to put it equal to 1 plus r because of the growth. All we have to do is subtract 1, and so now we have an r value equal to 0.259 ... Change it to a percent, and that's going to be 25.9%. And that's our r value, or our rate of change, or rate of growth in this case. Okay. Next one up. Again, what happens is that because that variable there is not by itself in my exponent, means I can't use my base as a true base yet. But if I go ahead and take that negative 0.3 and I take the base of 3 and raise it to that negative 0.3, I'm basically rewriting the equation into an equivalent form that would be h of x equal to 3 raised to the negative 0.3 gives me 0.7192 ... raised to the m. And now that m is by itself. And so we're going to go ahead and take that base and use it, since it's less than 1 more than 0. Oops. We're going to go ahead and say that this is decay. And now we can take that 0.7192 and put it equal to 1 minus r since it's decay. We'll subtract 1. We'll divide by negative 1 so that we end up with an r value equal to 0.28077. And we'll change it to a percent by moving the decimal or multiplying by 100, and we end up with 28.077% equals our r value, or our rate. Okay, hopefully you're getting the hang of this. So next one, even though that's a k up in the air, the negative on it is going to change my base. So we're going to go ahead and highlight that negative. However, you have to know that that's technically a negative 1, and we'll highlight the negative 1 so that we can put it in our calculator and our 2/3. Okay. And so we are basically rewriting our equation to be f of x equal to 7. 2/3 raised to the negative 1 is actually 1.5, because remember, guys, a negative exponent really just flips your numerator and denominator in this case. Okay? But now it'll be raised to the k. And now I can say that my base is 1.5, which is greater than 1, so we can go ahead and say that it's growth. And we can take that 1.5 and put it equal to 1 plus r, since it's growth. Subtract 1, and we get a rate equal to 0.5. But as a percent, 0.5 is actually 50% as our rate of change or rate of growth. Okay, next one up. Again, our exponent is not just x, and so we're going to have to type in the negative 0.5 as the exponent on the e. And so what we're doing is we're rewriting this equation so that our exponent is just x. Okay? E to the negative 0.5 ends up being 0.6065 raised to the x. And now we can take that base and say that our base is 0.6065 . Since it's less than 1, more than 0, we're going to go ahead and say decay. And because it's decay, we're going to take that decimal and put it equal to 1 minus r. We're going to subtract 1 and divide by negative 1 so that we get our r by itself. And it would be 0.39346 ... times it by 100 to move the decimal, and we end up with 39.346% as our rate. Okay, one more on this side. Again, our exponent is not just our single variable of t, and so we're going to take that 1.4, we're going to raise our e to that 1.4, and again, we're basically rewriting our equation to be f of x equal to 4.055519 ... raised to the t. And now that our exponent is just our variable t, we could go ahead and say our base is 4.05519 ... It's definitely over 1, and so this is definitely growth. And we're going to take that 4.05519 number, put it equal to 1 plus r, since it's growth. We'll subtract 1, and our r comes out to equal 3.05519 ... We will multiply by 100 or move the decimal 2 places, and we end up with 305.519%. That's a big percentage. That's a lot of growth. Okay, so hopefully you guys understand that when you look at what the exponent's on, if the exponent isn't just an x, that might not be your true base. And so I don't want you to assume that it's growth or decay just by looking at the base and the base alone. You have to make sure that the base is raised to just a single variable exponent. All right. All right, I'll see you guys on the back side of notes.